As you know that the concept of set itself very interesting and useful also to solve a day-to-day life situation problems. Today we'll discuss subsets. What is a subset? Definition. We'll take a standard definition of subset. If we have two sets, a set A is said to be subset of set B. Condition is if, look at this condition, if every element of set A is an element of set B. So look at this condition. Here every element of set A is an element of set B. In that case we used to say that set A is a subset of set B. We'll see this with some example. Suppose I have set A here which contains number 1, 2, 3, 4 and 5. I have another set B which contains number 1, 2, 3, 4, 5, 6, 7 and 8. Now we'll verify our condition of subset. Look at, 1 is a member of set A which is also member of set B. 2 is a member of A that is in B. 3 is a member of A that is also here in B. 4 is a member and it belongs to B. 5 is a member of A, it belongs to B. Means each element, each member of A is also member of B. Means A is a sub part of B. In that case we used to say that A is a subset of B. But how to write that A is a subset of B? We used to write A is subset of B. Read this as A is subset of B. So this is a notation of subset. As we already discussed earlier, how to represent element of set A. So every element of set A is element of set B. The same thing we can write in short. This is a notation for all. Read as a for all X is in A, X is member of. This notation is belongs to, or it is used for member of, isn't it? So X for all X in A implies X in B. In that case we used to say that A is subset of B. Now look at in this case, here we have set A which contains 1, 3, 5, another set B which contains 1, 2, 3, 4, 5 and third set is 1, 2, 3, 4, 5. मीन्स यहाँ पे 3 सेट है. A में कुछ मेंबर्स हैं, B में भी 5 मेंबर हैं और C में 6 मेंबर हैं, 6 मेंबर्स होते हैं. If you observe all these 3 sets, we have to identify whether one of the set is subset of another. 1, 3, 5. Are these members are the member of B or C? All members. 1, 3, 5. 1 is here, 3 is here, 5 is also here. So can I say A is a subset of B? Yes, definitely, because by criteria every element of set A is a member of B. So I can say A is subset of B. Now we'll check whether B is a subset of C. 1, 2, 3, 4, 5. Is it there in C? 1, 2, 3, 4, 5. Yes, all members of B are also members of C. So I can say B is subset of C. Now look at here. Every element of B is an element of C. यहाँ के सभी members C में हैं. So it is easy to say that B is subset of C. Now, whether A is a subset of C, what are the members of A? 1, 3, 5, and here I have 1, 3, 5. So each element of set A is an element of C. So that's why A is subset of C. So like this, we can identify whether the given set is subset of another set, and if every element of set A is an element of B, and similarly, if every element of set B is a member of set A, in that case, these two sets are equal set. Look at this another example. Set A contains members A, B, C, D, and set B contains member A, E, I, O, U. Now we'll try to check whether A is a subset of B or B is a subset of A. A is here, A is in B also. B is a member of A, which is not member of this set. So I cannot say that A is subset of B. So A is not subset of B. Even one member of one set is not a member of another set, then it is not subset. This is a notation for not subset. Whether B is a subset of A is here, in this set also A. E is not member of this set A, so that's why B is not subset of A. Look at here. So I have a set N which contains 1, 2, 3, 4, which is a natural number. Second set of integers. Integer में क्या होता है? पूरे positive numbers और negative number together. Rational numbers, the number which is in the form of P by Q, where P and Q are integers, means any number which has a numerator and denominator, where numerator and denominator both are integer, means from these numbers. Set of real numbers, all the real numbers means rational as well as irrational together are called real number. Is there any order in this set? Means can I say one set is a subset of another set? Look at here. Natural number contains 1, 2, 3 up to infinity. And all natural numbers are here in integers also. Isn't it? 1, 2, 3, 4 up to infinity. This side also up to infinity. So I can say natural number is subset of integer. Now next point. Integer. So minus 3 can be written as, how can we write minus 3? Minus 3 can be written as minus 3 by 1. So every integer is a rational number. So every integer is a rational. So integers are subset of rational numbers. But every rational number is again considered as a real number. So each rational is a real. So this is a sequence. All naturals are integer, all integers are rational, all rationals are real, but not only rational, irrational numbers are also real numbers. What are intervals? Intervals are subsets of, what are intervals? Intervals are subset of real number. Consider a real number, you know the real line. If I have a real line, means set of all real numbers, you know that every real number can be associated with unique point on a number point. If I consider one point from here, that is associated with one of the real number, isn't it? So if here is a 0, and if I take part from here, say here point A, real number A and real number B. So I got interval from A to B. So we can differentiate this interval. If you want to include A and B in that interval, then another set. You can exclude A and B from that. That would be another set. You can exclude only A, or you can exclude only B. We'll see the types of interval. First of all, open interval. How to write open interval? We used to write symbol as AB. Open interval AB. What is it? We'll see. I have here A and B. This hello circle means A is not part of this interval, B is also not part of interval. So interval itself a set. Interval AB is set of all x, means all real number, such that x is a real number. Real, it is a member of real part. इसमें क्या है? Real पूरा real, उसमें से हम कुछ real number ले रहे हैं continuously. What is the condition for that? X is strictly greater than A and strictly greater than A and strictly less than B. What does it mean? X is not equal to A and X is not equal to B. Means whatever number here, that belongs to interval. Number over here belongs to interval. So each element between A and B, but A and B are not included, that is considered as interval AB, which is open interval. Now next to that, closed interval. Closed interval is denoted by square bracket. What does it mean? A and B are also part of the, so this is dark dot. Now what does it mean? Close interval A and B. Look at here, same thing, set of all real numbers, where set of all x, where x is a real, and how is the x? X is greater than equal to A and less than equal to B. So what is the difference in open and closed interval? In open interval, A and B are not member of that interval. So interval itself a set because all the numbers are collected, continuous. Not only A and B. Look at this bracket. We are using open bracket, not the curly bracket. Means excluding A and excluding B, all the members between AB are in a open interval. But in a closed interval, including A and B and all the elements between AB are the parts of interval. So this is a set. Semi-open and semi-close. Semi-open and semi-close means what? So one end A is excluded and B is included. How to represent it? This is not a member, so open. Open means A is not a member, and B is included, so it is a member. Member means square bracket. So this is semi-open, or you can say semi-close. Sometimes A is a member but B is not member. Hello portion. So A is included, B is not included. Means यहाँ पे A member है, so we will use square bracket because A is a part of interval, but B is not a part of interval, so we will keep the bracket open bracket. This is sign of open bracket. So like this we understood open interval, closed interval, semi-open, semi-close. We'll take one more example. If I say A is a set of all x such that x belongs to R, means x is real number, read as x is a real number, and x is between 3 to 7. What does it mean? Is it open or close? Look at here. Strictly less, strictly less. So 3 and 7 are not included in A. So I can write this as a 3, 7, open interval 3, 7. Another example, B. Set of all x such that x is a real and 5 less than equals to x less than equals to 10. How to write this interval? This is a set. I want to represent this set in the form of interval. Sometime you are supposed to represent intervals in the form of set. The same set I can write in the interval form. 5 is equal, so square bracket, 5 is included, comma, 10 is also included, so close. So this is a close interval. Another example, set of all x such that x is a real number, 5 is strictly less than x less than equals to 10. Now in this case, 5 is not member but 10 is a member. 5 is not member, so this side open, comma, but 10 is a member because 10 is equal to x is less than equal to 10. So 10 is a member, so this side close. So this is a semi open, semi close. Another set of all x such that x is a real number, 5 is less than equals to x and strictly less than 10. So I can represent this set in the form of interval as this side is close, 5 is included, and this side is open.